A control valve acts like a variable orifice. Variation of this orifice is obtained by partial opening or closing of a poppet. This is normally closed when no pressure exists inside the valve. Under pressure, the valve opens immediately after the upstream pressure under the membrane becomes greater than the force of the spring. When upstream pressure is applied via a pipe circuit onto the top of the membrane, the valve will close. If we complete the pilot circuit with a downstream pressure pipe and a three-way manual valve in order to keep upstream pressure on the membrane of the main valve, it keeps closed. Let's move the three-way valve. The three-way valve allows pressure from over the membrane to go downstream, thus freeing the closing system of the main valve, and it opens. In practice, this three-way manual valve is replaced by an automatic pilot valve which causes the movements of the main valve to follow it and thus ensure precisely all the different functions. A variety of accessories complete the pilot circuit. An orifice. This gives priority to evacuating the pressure above the membrane of the main valve. Isolating valves. These assist with maintenance. And a strainer, which protects the pilot circuit. Thanks to a combination of different pilot valves, the control valve can control downstream or upstream pressure, maintain a differential pressure, evacuate overpressures, control a level, control flow, obtain total opening of the valve, protect a pump, and act as a check valve. The distribution pressure in the village is reduced and stabilized to a preset level, which is maintained despite variations in the valve's upstream or downstream pressures. This is a C101 pressure-reducing valve. At first, the downstream pressure is at the required level. The closing system of the main valve and the pilot valve are both open at a given position. When demand for water increases, the downstream pressure will drop. As it drops, it will no longer be sufficient to counter the strength of the pilot valve spring, which causes the closing system to start opening. The pressure above the membrane of the main valve escapes downstream through the pilot valve, which causes the main valve to open even wider. This opening of the valve allows the downstream pressure to increase and progressively return to the desired level. Meanwhile, the pilot valve returns to its original position, causing the main valve to follow suit. When the demand for water decreases, the downstream pressure will rise. The pressure under the membrane of the pilot valve thereby increases, overcoming the force of the spring and causing the pilot valve to begin closing. Pressure upstream of the pilot valve will increase and be applied to the membrane of the main valve. This will cause the closing system to move towards the closed position. This closing movement allows the downstream pressure to be reduced until the preset level has been reached, whereby the pilot valve and main valve closing system will return to their original positions. Another frequent case, for example, is the need to maintain a minimum preset pressure upstream on the city side, regardless of pressure variations downstream on the village side of the valve. This is a C301 back pressure valve. In this example of back pressure application, the pilot valve is opened in a given position. The closing system of the main valve is open too. Upstream pressure is equal or over the setting pressure. Upstream pressure falls below the preset level. It's therefore no longer able to overcome the strength of the pilot valve spring, which causes the pilot valve to close. The main valve will also close in order to increase the level of upstream pressure. When the upstream pressure returns to the preset level, the pilot and main valve open again. In this situation, the requirement is to maintain a minimum pressure upstream of the city side and to ensure that pressure on the village side is not too high. The C104 valve combines both functions by incorporating pressure-reducing and back-pressure pilot valves. Control valves can also be used to protect installations. For example, the C500 series valve reduces water hammer when installed in a bypass. The C600 series controls and protects pumps when installed on the line. It's also possible to control the filling and water level of a storage tank using the C200 series altitude valve or a C700 series float valve. Finally, we can control the feed flow to any industrial, commercial or agricultural zone regardless of changing upstream or downstream pressures in the system by using a C900 series control valve.